Hello, I'm Aaron and I welcome you to Let's Learn. I'm taking you through mathematics. In today's edition, we'll be dealing with sets. What is set? A set is a collection of objects of the same kind. For example, we have a set of numbers. We have 1, 2, 3, 4, 5, and 6 as a set of numbers. A set of alphabets. We have A, B, C, D. A set of names. We have Na, we have Kweku, we have Yao. These are all examples of sets. The objects that are found within the curly brackets of a set are known as elements. Therefore, the 1 here is an element, the 2 here is an element, the 3 is an element, and that of Kweku and Yao are all elements. A set is always placed in a curly bracket to show the beginning and the end of it. For this reason, we are going to be talking about the types of sets. There are two main types of sets. Of which are 1. A finite set. A finite set can be defined as a set which has its last element being known, in the sense that when you have a set with its last element being known, we define that as a finite set. And an example of it is a set of numbers. We have 2, 4, 5, 6, and 9. Since the last number or element, that's 9, is being known, this makes this set a finite set. Another example is an example of names of girls. A set of names of girls. You have Ama, you have you have Isi. Since the last name here is also known, it is a finite set. The next type of set is an infinite set. Infinite. An infinite set is a set that do not have its last element being known, in a sense that it continues to infinity. For example, we have a set of even numbers. We have 2, 4, 6, 8, with our 3 dots. These 3 dots in here illustrates the fact that the numbers goes on and on and on, making it an infinite set. Another example is a set of animals. You have a dog, a cat, a rat, and goes on and on and on. The most important thing here that will show you that the set is either a finite set or an infinite set is these three dots. Immediately you see these three dots, it shows that the set is an infinite set and that it's not a finite set. Terms used in sets. The first term we are going to be talking about is the universal set. I know a lot of you have an idea about a universal set, and I say a universal set is a set that from which subsets are being gained from. An example is a set of A. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Another set, that set B, has elements of 1, 2, 4, 6, and 10. And the last set, set C, has elements of 7, 9, 8, and 2. From these illustrations, you can find out that set C can be, the elements of set C can be found in the elements of set A, and that of the elements of set B can be found in the elements of set A. Therefore, the set A is being the universal set of both set B and set C, and the universal set has its own symbols, which are a U and this symbol. The next is the subset. As I said in the universal set, subsets are being gained from the universal set as illustrated, and that an example is the set B. So set B, that's 1, 2, 4, 6, and 10. It's a subset of set A and set C. Set C with elements 7, 9, 8, and 3 is also a subset of set A. The next is the union with symbol this. It looks union with the symbol U without a bar under it. Therefore, the union brings two sets together. Using the example used in the universal set, which has set of set A, set B, and set C, let's unite set B and set C. Therefore, we have elements of 1, we have 2, we have 3, we have 4, we don't have 5, so we have 6, we have 7, we have 8, we have 9, and the last one to be 10. The union unites both the set B and the set C, which has to be in a sequential order. Intersection. It's also a symbol that looks like an N. The intersection deals with the fact that two sets may have a common element. For example, we have two sets as set X with members 2, 4, 6, 8, and 10, and that of set Y with members 1, 2, 3, 5, 7, and 9. From these two sets, let's see if we can use these two sets to explain the intersection. From set X, we could see a common element between set X and set Y, which is a 2. Since the element 2 is located within the set X and also located in the set Y, we can have the intersection of X and Y to be 2. A unit set. When we talk about a unit set is any set that has only one element in it. For example, we have a unit set of this, and this. Since they all have one element in them, it is a unit set. A null or empty set. When we talk about a null or an empty set, a null set is any set that has no element within it, and it has a symbol of this. Actually, this is also a null set since it doesn't have anything within it. Another symbol for it is this. An equivalent set. An equivalent set is any set. The equivalent set deals with two sets. When I talk about equivalent set, it only occurs when two sets have the same number of elements within it. Therefore, we have a set of F. Thus, we have 1, we have 2, and we have 3. Then set E with elements 11, 12, and 15. Since set F has 3 elements in them, and that of set E also has 3 elements in them, we can say that set E and set F are equivalent sets, equal sets. When we talk about the equal set deals with the fact that the elements of both sets should be the same. For example, we have set P to have elements of C, A, and B, and set O to have elements of A, B, and C. Therefore, since we have the same element, we have a C here, we have a C here, we have an A here, we have an A here, we have a B here, we have also a B here, it is an equal set. Prime numbers. A prime number is a number that has only two factors. Thus, its factors are 1 and itself. And examples of prime numbers are 2, 3, 5, 7, 11. Without 3 dots, so it's up to infinity, making it an infinite set. The next is an even number. An even number is any number that can be divisible by 2. Therefore, we have examples to be 2, 4, 6, 8, so on. We have odd number. An odd number is any number that cannot be divisible by 2 to get a whole number. For example, we have 1, 3, 5, 7, 9, so on and so forth. The last thing we'll be talking about is the Venn diagram. The Venn diagram was brought by Mr. John Dane. This Venn diagram is an illustration of sets. For example, using our set used in the universal set, we have a set A, set B, and set C. So we have set A. Let's illustrate set A, set B, and set C. Since set A is a universal set, let's illustrate those ones in a Venn diagram. The U here is the symbol for the set A, that's the universal set. Now, we have our first one to be set B and the second one to be set C. The members of set B are 1, 2, 4, 6, and 10. And the members of set C are 7, 9, 8, and 3. This is an illustration of the sets of the examples used in the universal set explanation. Therefore, we are not done. We have some elements that were not parts. So that is 5. Using Mr. Venn's diagram, we have illustrated the example used in the universal set. Another example is using the example used for the intersection. Thus, we have this. It's our U. We have our X, and we have our set Y. Let's list the members. We have 4, we have 6, we have 8, and we have 10. We also have 1 in set Y, we have 3, we have 5, we have 7, and we have 9. You are wondering why I didn't write the element set 2. Since set 2 can be found in both X and Y, that is the intersection. Talking about the intersection will be written in this side where both circles meet. Therefore, the intersection here is 2. This brings us to the end of this lesson. Thank you.